7.4 notes, similarity in right triangles. For our warm-up, I would like you to factor this quadratic expression. In order to factor this, we need to think about factors that multiply to 49 and add up to negative 14. Think about two numbers that multiply to 49 and add to negative 14. Negative 7 and negative 7. So in order to factor this, we can rewrite the middle term. So instead of negative 14x, we'll rewrite it as negative 7x and negative 7x. So we have x squared minus 7x minus 7x plus 49. Then we can factor by grouping, where we group the first pair and the second pair and factor out GCFs. The GCF for the first pair would just be x, and then you would be left with x minus 7 in parentheses. We're going to bring down the sign, which means ultimately we're factoring a negative out of the second pair, and we're factoring a negative 7 out of there. And if you do that, in parentheses you'll be left with x minus 7. We can rewrite this as the product of two binomials, x minus 7 times x minus 7. Or we could write that in a simpler way, x minus 7 squared. Number 2, we're going to solve the equation x squared equals 4x. Remember, when we solve quadratics, we want the polynomial to equal 0. So x squared minus 4x equals 0. That's just subtracting 4x from both sides. We're going to factor out GCF, x, which would leave us with x minus 4 in parentheses. Then we're going to use the zero product property to set the two factors equal to 0 and solve for x. So x equals 0 and x minus 4 equals 0, so x equals 4. Today we're looking at similarity in right triangles. Theorem 7.3 talks about the altitude to the hypotenuse of a right triangle divides the triangle into two triangles that are similar to the original triangle and to each other. So what this altitude does is it really breaks up the right triangle into three triangles: a small triangle, a medium triangle, and a large triangle. You can see all three triangles in this example. So it says triangle ABC is similar to triangle ADC. That would be the big triangle is similar to the small triangle. Then triangle ABC, the big triangle, is also similar to triangle CBD, the medium-sized triangle. And then ultimately, or last, triangle ACD is similar to triangle CBD. So small triangle is similar to medium-sized triangle. Part A says, write what similarity statement can you write relating the three triangles in the diagram. So again, we're looking at the small, medium, and big triangle. So for A, we can say triangle QSP is similar to triangle PSR. Small is similar to medium. QSP is similar to QPR, so small is similar to big. And then lastly, triangle PSR is similar to triangle QPR. And that would be the medium is similar to the big one. Part B. From the similarity statement in Part A, write two different proportions using the ratio SR to SP. So what I'm looking at is the long leg SR of the medium triangle over the short leg SP of the medium triangle. So if I'm going to compare long leg to short leg, I would have to compare it to the long leg and the short leg of another triangle. So the long leg and the short leg of the big triangle are PR and PQ. So SR over SP equals PR over PQ. And SR over SP would equal the long leg SP over the short leg SQ of the small triangle. geometric mean. The geometric mean is a over x equals x over b. What this allows you to do is to find the geometric mean for two numbers. So when it says find the geometric mean of 6 and 15, we're going to be plugging 6 and 15 in for a and b. X is our geometric mean, so we do the cross product property here. X times x is x squared. 15 times 6 is 90. We're going to square root both sides and get x equals the square root of 90. Now we're going to simplify the square root of 90. So using our factor tree, that breaks down to root 9, root 10. The square root of 9 is 3, and square root of 10 cannot be simplified, so our final answer is 3 root 10. The geometric mean of 6 and 15 is 3 root 10. The length of the altitude of a right triangle is the geometric mean of the lengths of the segments of the hypotenuse. So what this means is 4 over x, and just realize that's short leg over long leg of the small triangle, equals x over 18. That's short leg over long leg of the medium triangle. So then we just cross multiply. 18 times 4 equals x squared. So x squared is equal to 72. We want to break down root 72. That's root 36 root 2. Root 36 is 6, so x equals 6 root 2. So you can see here how we can use the geometric mean to find missing lengths. In this case, it's the length of the altitude of the big right triangle. The altitude of the hypotenuse of a right triangle separates the hypotenuse so that the length of each leg of the triangle is the geometric mean of the length of the adjacent hypotenuse segment and the length of the hypotenuse. This is very wordy. This is hard to understand, but we can set up ratios to solve nonetheless. 12 over y, that's long leg over short leg of the medium triangle, equals long leg over short leg of the small triangle. So 12 times 4 is 48, and y times y is y squared. So break down 48. Root 48 is root 16 root 3, so y equals 4 root 3. So let's talk about ratios and what I like to call the triple triangle. Whenever you have an altitude of a large right triangle, it separates, or it breaks that triangle into 3 triangles. The original one, a small one, and a medium one. There are 3 different ratios to think about. The short leg over the long leg of the right triangle, so that's true for small, medium, and big. The short leg over the hypotenuse for each of the 3 triangles, and the long leg over the hypotenuse for all 3 triangles. So you can use these different ratios to find missing lengths within the triangle. So let's take a look at what this looks like. Here we have an example where we need to find 2 missing lengths, x and y. We have 3 triangles, right? A small, a medium, and a big. So we just have to decide what we're given and if we have enough information to solve for either one of our variables. The first one, I have enough information to solve for x if I were to go short leg over hypotenuse. So notice in the small triangle, short leg over hypotenuse, that's 4 over x. And then the big triangle, the short leg is x and the hypotenuse is 4 plus 5, which is 9. So 4 over x equals x over 9. Cross multiply, we get x squared equals 36, so x equals 6. Now we have enough information to solve for y. We had enough information before. Remember that the altitude there is the geometric mean of the 2 segments it splits. So in this case, we're going to go short leg over long leg of the small triangle equals short leg over long leg of the medium triangle. So 4 over y equals y over 5. Y squared equals 20. Break that down, we get y equals 2 root 5. Your homework for 7.4 is on mathexcelforschool.com, due Sunday at midnight.